Hello, everyone. I'm going to show you how to do a one-sample t-test. Let's look at an example. A certain intelligence test is designed to have a population of scores following a normal distribution with a mean score of 100. Below are scores on this intelligence test from 6 randomly selected undergraduate students from Thorndike University. All right, so first it's important to distinguish between quantitative data and categorical data. So remember, we use proportions for categorical data. In this case, we are given scores. So we are looking at quantitative data, and we're going to be using a t-distribution model, just like when we did our confidence intervals. And the first thing we're going to do is state our hypothesis, our conditions, mechanics, and conclusion. So let's go ahead and pull out the important information from the paragraph. So the first thing is that they tell us that the mean score is 100. That is a population mean score. So that is our mu. That equals to 100. And they are giving us a list of 6 randomly selected students and their scores. Now, the important thing is our sample size is 6, however, which is less than the required 30. However, in the paragraph, it states that the scores are normally distributed. So that is important when we're stating and checking our conditions. So let's go ahead first and state a hypothesis. So our hypothesis is that we have our mean is equal to 100, that's mu, and our alternative, which is in the question, is asking, the question asks, does the population of undergraduates of Thorndike University have a higher than average intelligence score? I want to know for alternative if it is greater than 100. So here is our hypothesis statement. Now, it's important to define our population, and it is defined right here. I wrote it as mu is equal to the intelligence scores of Thorndike University students. All right, let's take a look at the conditions. The first thing is we're going to check to see if the sample was taken randomly. It does state here that it was randomly selected right here, 6 randomly selected. So the first condition is met. The second condition, as we stated before, states that it comes from a normal distribution. So remember, you either have to have a sample size greater than or equal to 30, or somewhere it states normal, or you show using a box plot or normal probability plot. If they don't give it to you, that you're showing some type of graph where it's normally distributed. The third condition is we want to show that our population is greater than or equal to 10 times n. Our sample size is 6, 10 times 6 is 60, and we can say there are more than 60 students in the populations. Conditions met, we will use a one-sample t-test. Let me go ahead and show you how to do that on a calculator. So in our calculator, I actually already entered the list. I named it as scores. And now what I'm going to do is go to open a new page. All right, the first thing we're going to do is go to Statistics, Stat Tests, and then we're going to go to a t-test. From the t-test, it's going to ask us, just as when we did confidence intervals, if we would like to enter data or stats. Now, since we're entering a list, I'm going to keep it as data. Once we have our t-test, what we're going to do here is we're going to enter our population mean, which was given as 100. We could double check it over here. The population mean was given as 100. So I'm going to enter 100. Next is we're going to enter our list. I already named it as scores. And on the bottom where it says alternative hypothesis, we are testing greater than. Press OK, and here is our information generated. We can see that the test is greater than here. Our t-score is 3.15. Our p-value is 0.012. Our degrees of freedom is 5. Our mean is 120. Standard deviation 15.54. And our sample size is 6. I went ahead and I copy and pasted it over here, so it's like we're looking at our calculator. To save us time, I already typed out the mechanics. So let's take a look. The mechanics, first of all, you should mention your significant level, which is alpha equals to 0.05. You should also mention your degrees of freedom. Our degrees of freedom is equal to n minus 1, which would be 6 minus 1, which is 5. And then we have our test statistic. Our test statistic is our statistic, which is our X bar. Didn't leave much room for me to write here. All right, you always want to make sure you write your degrees of freedom. So I'm going to go ahead and write our degrees of freedom here. And that would be our n minus 1, which is 6 minus 1, which would give us 5. So I have my significant level, and I also have our degrees of freedom. Our statistic, which I wrote down in words, is actually our average, our sample average, minus our parameter, which is mu, over the standard deviation of the statistic, that will be S over the square root of n. So rather than write it in symbols, I wrote it in words, but here are the symbols. Now plugging in the numbers, our X bar, which is given right here, is 120. That is our sample mean. Our parameter is 100. The standard deviation is right here, 15.5435 divided by our sample size, square root of x, and our t-score is given right here. I plugged that in as 3.15. Now, very important to write down your p-value. Also given on this list, that is 0.012664. Now, we want to use that value to compare it to our significant level. Our significant level is 0.05. So when you state your conclusion, in the first sentence, you always state your p-value and compare it to your significant level. You're either going to reject or fail to reject. When the p-value is low, the null must go. So we could see that our p-value of 0.012664 is less than our alpha 0.05. So we will say we reject the null since the p-value of 0.012664 is less than alpha 0.05. We have sufficient evidence that intelligence score of Thorndike University students is higher than average. I basically restate what we stated in the hypothesis. So we rejected the null and we went with the alternative. Now, looking at our graph, you don't have to draw a curve, but it is helpful. What does it mean when we reject? So if we look at our mean is given as 100. Our sample is 120. Our t-score is 3.15, which means if our t-score is somewhere here, 3.15, this area under the curve here, that is the p-value that we got to be 0.012. So that is our 0.0126. And the significant level is 0.05. So that means our significant level, our alpha, somewhere here, is equal to 0.05. So if our sample falls anywhere past 0.05, in other words, to the right of it, we will reject. If it falls to the left of that, then we will fail to the reject because we don't have significant evidence.